Hi everyone, it's Math with AUB, day number 21 in connection for the preparation of ECAT, NET, AgaKhanBoard, Federal Board. Let's see and find out question number 21. What props up? Question number 1, based on de Moivre's theorem, and it obfuscates the reality. It is something like cumbersome. You should have a background. What is Euler identity? Written as Euler, pronounced as Euler, it reads that e raised iota theta is equal to cos theta plus iota sin theta. That is the tiny background. Utilize this and each and everything is nothing here. So by virtue of this, this is equal to e raised 2 iota theta overall power 5. E raised 2 iota theta overall power 5. Here it is not the situation, middle symbol is negative. Reconcile, make this symbol positive, make this symbol positive. It is, we can write cos minus 3 theta. By virtue that cos is an even function, so minus doesn't affect here, plus iota sine, it can be written as negative 3 theta raised 6. This minus automatically vanish by virtue that cos is an even function. Here sine is an odd function, minus will become here minus plus minus. Okay. What about this? Same situation is here. Turn this symbol into positive one, utilizing the same concept. Cos negative 4 theta plus iota sine negative 4 theta raised 7. Here it's already positive. It's tantamount to e raised 5 iota theta raised 8. Power, it will become 2 5 the 10 iota. 2 5 the 10 iota theta. Now it's equal to e raised minus 3 iota theta raised 6 and so on. Now let me write in black. We have cell through. It will become e raised 2 5 the 10 iota theta, and it's equal to e raised negative 3 iota theta overall power 6. Overall it's tantamount to e raised negative 4 iota theta raised 7, and it will become 8 5 the 40 e raised 40 iota theta. Now 6 is the 18, 4 7 the 28, 10 iota theta. E raised 6 is the 18 iota theta. E raised negative 4 7 the 20, 8 iota theta times e raised 40 iota theta. Basis same, they are in multiplication, add the powers. 10 iota theta minus 18 iota theta. In the same token, bases are same, they are in multiplication, add the powers. E raised negative 28 iota theta plus 40 iota theta. So what we have eventually, positive 10 iota theta negative, it is tantamount e raised negative 8 iota theta divided by e raised minus 28 iota theta plus 40, positive 12 iota theta. Now here bases are same, write in the numerator, it is tantamount e raised negative 8 iota theta minus 12 iota theta. So it's equal to minus 20 iota theta, or you can write cos negative 20 iota theta 20 theta plus iota sine negative 20 theta. By virtue of even function, cos is even, minus turn into positive 20 theta plus minus minus sine remains, negative sine remains, as sine is odd function, it's negative iota sine 20, there's 20 theta. 20 theta. That's the final answer in that question. I have solved your problem once for all. What do you mean by how to apply de Moivre's theorem, or applying de Moivre's theorem is something little bit complicated? No. Utilize this Euler identity. E raised iota theta is equal to cos theta plus iota sin theta, and it works wonder for you. Wonder for you. Look at this. Okay. Move to question number next. An elegant question in complex numbers. If Z1 and Z2 are two complex numbers, they are complex number. If they are collinear, collinear means, here lies the mystery. What do you mean by collinear? Collinear means either they lie along x-axis both or lie along y-axis. They are collinear. Collinear means lying on the same line. Collinear means lying on the same line. Collinear means lying on the same line. Now we have to prove what is true. Lying on the same line means either z1 is equal to x1 or z1 is equal to y1. Similarly, z2 is equal to x2 or z2 is equal to y2. Either both they lie on x-axis, they are pure real, or they lie on y-axis, they are pure imaginary. If that is the case, then which of the following is true? Then which of the following is true? Let's see and find out. Let's see and find out. Z1, option number 1 to be checked, Z1 plus Z2 is equal to mod Z1 plus mod Z2. That is the equality part of triangle inequality side. Z1 or Z, let me take both pure real. X1 plus X2, here only X1 plus X2. Finding their modulus, magnitude, the real part square plus imaginary part square, in that case imaginary part imaginary part, that's our 0 square, and here it is our x1 square plus x2 square. There is also no imaginary part, 0 square or 0 square. So we have square root cancel, it will become x1 plus x2. Here this is x1, this is x2. So our option number 1 is valid. If both the complex number are collinear, they both lie on x-axis or y-axis, means they are pure real or pure imaginary. They are pure real or pure imaginary, then this triangle inequality holds its equality. Then mod z1 plus z2 is equal to mod z1 plus z2. Okay. Question number 3, the final one. Look at this. That is the value of omega, but 2 from the denominator is missing. That's value of omega, that's value of omega square, but 2 is missing. 2 is missing. Value of omega is equal to minus 1 plus negative 3 or 3 iota over R2. So 2 has been shifted here. 2 omega is equal to minus 1 plus minus under root 3. In the same token, 2 omega square is equal to minus 1. There should be minus. I have forgotten. Minus 3. Okay. So instead of this, I can write 2 omega. Instead of this, I can write 2 omega square. It's equal to 2 omega raised 4 plus 2 omega square raised 4. Now distribute the power, it will become 2 power 4 omega power 4 and 2 power 4, 2 4 power having another power 2 for that. 2 power 4 common, what remains? That's omega 4 omega power 8. We are familiar, omega cube is equal to 1. Omega cube is equal to 1, that's the key here. 2 power 4 means 60. Omega cube 4 can be written as omega cube into omega. And omega 8 can be written as omega cube omega square, or one can break 3 square into omega square. I have written omega cube is equal to 1, omega cube is equal to 1, 1. So we have 1 times omega, 1 times omega square. 16. Omega plus omega square is equal to minus 1. So minus 16 is the right option in that case. What I have utilized? This identity, 1 plus omega square is equal to 0. Omega square is equal to 0. Within no time, within a short frame, I have compiled for you some tremendous question based on complex number. It's all by itself. Next.